Hello everyone and welcome back to Diksha Karnataka YouTube channel. You are watching KCET 60 out of 16 physics series where we are discussing each and every chapter concept wise, and we are also discussing previous year questions from each chapter, and every Sunday as usual we are conducting KPL or KCET Premier League. For that you have to join our WhatsApp group to get the question paper that is available in our WhatsApp group, and let me know in the comment if you have attended KPL 3 that is concluded yesterday. So today we are going to do the previous year questions from moving charges and magnetism chapter, a very important chapter. Almost 5 questions comes from this chapter every year, 4 to 5 questions. So let's start with the first problem. The torque acting on a magnetic dipole placed in a uniform magnetic field is 0 when the angle between the dipole axis and the magnetic field is. So we know that torque acting on a magnetic dipole is given by magnetic dipole moment cross the magnetic field in terms of scalar. We can write this as mb sin theta, right? Now if torque is 0, that means if m is not 0, b is not 0, only when sin theta is 0. So sin theta is 0, that means theta should be equals to 0 degrees, right? So only 0 is the correct option from the given options. Now let's move on. Now charged particles is subjected to acceleration in a cyclotron. As shown, the charged particle undergoes increase in its speed. Now cyclotron is now deleted, but I am giving you the answer. Only the gap between D1 and D2 is the correct answer. Let's move on. A proton and an alpha particle moving with the same velocity enter a uniform magnetic field with their velocities perpendicular to the magnetic field. The ratio of radii, now we know that mv square by r is equal to qvb. Why? This is the centripetal force required for circular motion. This is the magnetic force. Now when it is entering a magnetic field, it will rotate in a circular motion, and from this relation we can calculate the radius. Radius is mv, one of the v will cancel here, both are v's, right? So it will be mv by qb. Okay, so this is the radius of the path. So we can see that radius is directly proportional to mass. Now if mass of a proton is mp, then mass of an alpha particle is 4 mp, right? And alpha particle has 2 protons and 2 neutrons, so that means it has 4 times the mass of a proton, right? So we can write r proton divided by r alpha particle. Alpha particle is nothing but helium, so it will be mp is mp obviously, and divided by 4 mp, right? This is the way we write. So rp they have asked you respectively, and in the question it is mentioned proton first, so you should be careful what they have mentioned. So 1:4 is the correct answer. Now let's move on. A moving coil galvanometer is converted into an ammeter of range 0 to 5 milliampere. The galvanometer resistance is 90 ohm and the shunt resistance has a value of 10 ohm. If there are 50 divisions in the galvanometer turn ammeter, either sides of the 0, its current sensitivity is. Now this question was incorrect. It was given as a bonus question in that year, but I have corrected this question and I will solve this question. So what is the, first of all they have said it can measure a current up to 5 milliampere. Plus 5 milliampere, it will go from 0 to right hand side. If negative 5 milliampere, it will go from center to left hand side. So only 50 divisions we need to consider. We cannot consider -5 to +5, that is 100, that we are not considering. Now when 5 milliampere current is passing through the galvanometer, 5 milliampere current is passing in the circuit, that current is being measured by the galvanometer, but galvanometer is not getting that 5 milliampere current, it is getting less than that current. We know that formula also, Ig equals to, you might wondering where we are going to learn this, where we have learned this formula. Yes, I have discussed this. in the part where I have discussed conversion of galvanometer into ammeter. So please do check that video. Now I is given 5 milliampere, right? 5 milliampere means 5 times 10 to the power of minus 3. S, shunt resistance 10 ohms, galvanometer resistance 90, shunt resistance 10. So it will be 5 times 10 to the power of minus 3 times 10 by 100, right? So it's cancelled. So we can write 5 times 10 to the power of minus 4 ampere is the current through the galvanometer. Now to measure this current, how many divisions are there? There are 50 divisions. So the current sensitivity is given by maximum current divided by maximum divisions. So it will be 5 times 10 to the power of minus 4 divided by 50. Okay, so it will be 10, it will go up, it will become minus 10 to the power of minus 5 ampere per division. Okay, so the correct answer is 1 times 10 to the power of minus 5 ampere per division. Okay, now in that year they have given everything plus, so that was given as bonus. Now I have corrected this question, so it is a fine question now. Now this is a very interesting question, very interesting question. So what they have said, a positively charged particle of mass m is passing through a velocity selector. It moves horizontally rightward without deviation along the line y is equal to 2 mv by qb. Very interesting value with the speed of v. The electric field vertically downwards. So electric field is vertically downward. And magnetic field is into the plane of the paper. Magnetic field is into the plane of the paper and it is entering in this direction. Okay. Even though there are not much role of this electric field, but you will see what is the role played by this electric field. Magnetic field into the plane of the paper. Now the electric field is switched off at t equals to 0. So that's what I said. Electric field is not doing much except of very fine thing. The angular momentum of the particle about the origin at t is equal to pi m by qb. So let's look into this problem. So what is the velocity selector? Velocity selector is where QE, that is electric field, is equals to the magnetic field, that is QVB. Okay, from there we can find the velocity, that is the selected velocity, it is E by B. Selected velocity is E by B. If the velocity is exactly at that value, then only it will be able to pass. If it is not, then it will not be able to pass through that system. Now at t equals to 0, the system is turned off. Also we know that when it is rotating in a circular motion, okay, so it was suppose this is the magnetic field, and here is the origin. Okay, at y equals to 2 mb by qb, it enters the magnetic field, right? This was the y at the point of entry. Now we know that radius of rotation is given by mb by qb. We just solved it in our previous problem. Okay, so radius of rotation is given by mv by qb. That means y is basically 2r, right? Y is equal to 2r. Now how much time it takes to complete one complete rotation, that is called time period. Time period is basically given by 2 pi m by qb. I have done that while doing the theory part of this portion. So time period is given by 2 pi by mb. Here the time is given as pi m by qb. Okay, here the time is given as pi m by qb. So basically we can say this time is nothing but t by 2. Now what is this, the meaning of this time period? Time period means if this much time passed, then it would have been completed one full circle. This would have completed a full circle, but only half the time has passed. So only half the time has passed means, and when it completes a full circle, this radius would have been r. Right? Now only half the time has passed, so that means it would be completing only half circle. It is entering here, and this distance is 2r. This distance is 2r, right? So this radius it should be rotating around somewhere here. So rotation, this is r, this is r. Okay, now at this point it is located at origin itself. Okay, so that given time it is located in at the origin itself. Now we know that angular momentum is given by r cross mv. Okay, here r is our distance from the origin, from the point of observation, right? So r cross mv is the angular momentum. Now r here is 0. mv has some value, does not matter, so angular momentum is 0 in this case. Now there are multiple different versions, multiple different solutions was available, and some people said that this is a bonus question in that year, but actually it is not. It is a valid question because the option 0 is given. Okay, some people have solved it incorrectly and they have found some wrong value, so those solutions are also available in YouTube. You can go and don't get confused. This is the correct answer. This is the actual answer for this question. Okay, now let's move on. A metallic rod of mass per unit length 0.5 kilogram per meter is lying horizontally on a smooth inclined plane which makes an angle 30 degree with the horizontal. A magnetic field of strength 0.5 Tesla is acting on it, the vertical direction, when the current I is flowing through it. The rod is not allowed to slide down. The quantity of current required to, I have solved this question during my class as well. So I told you, only thing missing in this question is the diagram. Otherwise it is very difficult. Now when the rod is lying like this and the current is flowing into the paper and the magnetic field is downward, so the magnetic force will be perpendicular to both of them, direction of current as well as the magnetic field. So the magnetic field magnetic force will be acting in this direction and weight of the wire should be in this direction. Now there should be a component of the weight. If this is mg, this is theta, then we have learned that this component is mg sin theta, right? In our first PU while solving friction problem, not gravitational, work energy problem, we have learned that there are two components. One is this component, cos theta component, another one is this component. Now the cos theta component will be balanced by the normal component. Okay, normal component, whatever is this in this direction. Actually there will be two components, one due to weight, one due to the magnetic field. They will be balanced by the normal force. Now but there will be another component in this direction that won't be able to balance it. Okay, only one thing that can balance it is this component. Now if this angle is theta, this is similar angle, so this angle will also be theta. So if this is the magnetic force, I am saying magnetic force FB, so this will be FB cos theta, right? So basically it means that FB cos theta equals to mg sin theta. Now what is FB? That is the main thing. So magnetic force, we know that acting on a current carrying conductor is Bill sin theta. Okay, but here they are perpendicular, so sin theta is 90 degree, sin 90 is 1, right? So it will be only BIL. That is a different angle. Remember that. That is the angle between the current and the magnetic field. Current and magnetic field are perpendicular, so that's why the sin theta is 0. This is a different angle. So some people confuse this problem because of this simple thing and they have made mistakes. So BIL, let me simplify this. So sin theta by cos theta, sin theta is what they have asked you to find. They have asked you to find the value of current, right? So BIL cos 30. Cos 30 is 1 by root 2 is equal to mg. Sorry, cos 30 is root 3 by 2. Cos 30 is root 3 by 2. Mg sin 30 is 1 by 2. So 2 cancels. Okay, or we can write that I equals to mg by BL, okay, root 3. Okay, now what is M? M is 0.5 kg. Okay, per mass. So m by L is given. M by L itself is given. Okay, 0.5 kg per meter. So m by L is given. So we will put that value 0.5. G assume 10. Okay, B is given as 0.25 and root 3. Okay, so it will be 0.25, 0.5. 0.25 is basically 0.5 is double of 0.25, so it will be 2. So it will be 20 by root 3. So what we can do? We can simplify it. 20 root 3 by 3, right? We can assume that. Now the simplest solution is make this 20 as 21, so it will be 7 root 3. This is the nearest solution. We cannot use calculator, so we have to use our head, we have to use our brain to solve this problem. Now what is the value of root 3? 1.7 approximately. So now multiply, so it will be 7 on the 7 plus 0.7 times 7, that is 4.9. It will be about 11.9, but slightly less than 11.9. Okay, so it will be 11.32. Okay, why 11.32? Because we have assumed this number to be 21. So we increased while doing the assumption. So if we increase while doing the assumption, the final answer should be less than that whatever we have obtained. And if it is if we decrease the assumption, then final answer should be more than the calculated value. You should remember this thing. Okay, now what I have done here, some people may ask, sir, what you have done here? 7, what I have done, this is also one calculation trick. 17 by 7, you can use your normal regular method. Okay, 7 4s are 49, in hand 4, 7 1s are 7, 4 11, so and 1 decimal, so 11.9, that is also fine. Okay, or what I have done, I have multiplied 1 times 7, that is 7. Okay, plus 7 7s are 49, 49, there was 1 decimal, so 4.9. This is, I feel this is easier for me to calculate. You can calculate using this old traditional method as well. Now let's move on. A galvanometer of resistance 50 ohm is connected to a battery of 3 volt along with resistance 2950 ohm in series. A full deflection of 30 divisions is obtained in the galvanometer. In order to reduce this deflection to 20 divisions, the resistance should be, so what is the given value? So given value voltage is 3 volts and the total resistance is resistance of the galvanometer plus external resistance, that is 50 plus 2950, so it is 3000 ohm. This is the resistance. Now what is the current? At this time current is V by R. V is 3 divided by 3000. It is 10 to the power minus 3 ampere is the current. Now this is the current when you are getting 30 divisions, 30 deflection, 30 scale deflection. Now if you want to reduce the deflection to 20, then what you have to do? You have to reduce, you have to increase this resistance so that current reduces. Okay, so for 20, this is for 30 divisions, 30 scale division. Okay, to make that 20 scale division, suppose I require a current of Ig dash, that should be equals to this current 10 to the power of minus 3 times how much we need? We need 20. How much it was? It was 30. Okay, simple unitary method. 2/3 times 10 to the power of minus 3. This is the required current. Again, we know that this should be equals to the applied voltage divided by the resistance, new resistance. Okay, applied voltage is remaining same, that is 3 volts, and new resistance, say R dash, and that current is 2/3 of 10 to the power minus 3. Now let's do the cross multiplication. So R dash equals to 9 by 2 times 10 to the power of 3. Cross multiplication, it will come up, it will come down, this will come down, but minus, that means it will go up and become positive. right? Simple. 4.5 times 10 to the power of 3, that is 4500. 4500, this includes the resistance of the galvanometer, right? So the resistance of the galvanometer is included. So final answer, resistance answer is 4500 minus 50, that is 4450 ohm, right? So 4450 ohm is the answer for this question. Now let's move on. A circular coil of wire of radius r has n turns and carries a current I. The magnetic induction B at a point on the axis of the coil at a distance √3r from this center. I have also solved this question. So what is the problem? We know that magnetic field on the axis of a circular coil of turn n turn is given by mu naught Ni r square. Here they have given small r, so let me use small r only. Okay, in the formula that I told you, I have used capital R because generally for radius we use capital R. Okay, 2 times x square, x is the distance, plus r square to the power 3 by 2. Okay. Now they have asked you to find the magnetic field when x equals to √3 r, right? So B equals to mu naught Ni r square divided by 2 times. So what is x square? X square will be 3r square, right? It was √3r. So if you square both sides, √3 will become 3, r will become square, r square, right? So it will become 3r square plus r square to the power 3 by 2, right? Now solve it. Mu naught Ni r square divided by 2, 4r square to the power 3 by 2. Now what is the meaning of 3 by 2? 3 by 2 can be written as mu naught Ni r square to, first of all we have to take care of this by 2. So by 2 means square root. To the power is already there. Okay, so we have taken care of by 2 part. Now let's solve it. So B equals to mu naught. So if you are very good in this mathematics, you can skip multiple steps and solve it quickly, but since I am doing it for all of the students, I am taking a little bit of time and solving it step by step so that you don't miss out any single steps and don't make any mistakes. Okay, so if you think, okay, I am very good in this, I can solve it without thinking too much, then you can do that also. And now fast forward this part. Okay, this is mu naught Ni by 16r. Mu naught Ni by 16r. Option A is the correct answer. Question number 9. A proton moves with a velocity of 5 times 10 to the power of 6 joule j cap meter per second through the uniform electric field E equals to 4 times 10 to the power of 6 value is given, and the uniform magnetic field B is equals to 0.2 Tesla. The approximate net force acting on the proton is. So first of all, what is the formula of the force acting on a charge? So force acting on a charge is Q times C, okay, plus Q times V cross B, right? This is the Lorentz force. So what we will do, we will take the Q common first, okay, and we will try to calculate E plus V cross B. Now which term we have to calculate first? Obviously first term we have to calculate V cross B, right? If you calculate V cross B, then we can vectorially add it with E and then find the magnitude. Once the magnitude is done, then we can multiply it with the charge of the proton, right? So first we have to calculate the V cross B. V is given 5 times 10 to the power of 6 j cap. Okay, I am not using unit here. Unit is fine as long as everything is SI unit. there is no chance of mistake. Only mistake you can make is in the calculations, right? Because units are only when you are solving in your PU board. Don't forget to mention the units. Also you have to check the units if everything is in SI and the unit in the final answer. There you have to check it thoroughly. Now we know that when we are cross multiplying three vectors I cap, j cap and k cap, and if we go in this order, I, j, k order, then everything is positive. That means I cross j is k, k cross I is j, okay, and j cross I is k, right? But I cross j is k, but if you are multiplying j cross I, then you should get minus k, right? If you are multiplying j cross I, then you should guess minus k. Also similar multiplication becomes 0. That means if you are multiplying v and b, okay, so j cross j term will become 0. Okay, first is the constant. Now v cross b, let us take care of the constant. 5 times 10 to the power of 6 times 0.2. Constant is taken care. Now first is v, right? So j cross I, j cross I means we are going opposite to the given direction, so that means it will be minus k cap plus this is j cap, so j cap becomes 0 plus now j cross k is I cap, okay, and there is only one, so only I am writing I cap. Okay, so now let's multiply. It will be 5 to the 10, but there was 1, so 1 times 10 to the power of 6 I cap minus k cap. Okay, so we have calculated v cross b. Now we have to calculate the force, magnitude of the force. So to calculate the magnitude of the force, what we have to do? We have to first calculate E cross v cross b. Okay, what is E? E was 4 times 10 to the power of 6. If you see, v cross b is 10 to the power of 6, whereas E is 4 times 10 to the power of 6. So if you take this 4, multiply every number with this 4, okay, then only 10 to the power of 6 will remain. That we have to take, we can take that common, right? So what we have to do? We have to use 10 to the power of 6, then 8 I cap plus 0.8 j cap and 0.4 k cap. From this we got only I cap minus k cap, right? This is from the v cross b. This is v cross b, this is E, okay, and we have taken that 4 inside so that we can take 10 to the power of 6 common, right? So 10 to the power of 6 remains common. We get 9 I cap plus 0.8 j cap minus 0.6 k cap. Okay, 0.4 minus 1 is minus 0.6. Now what is the magnitude of this? The magnitude of this is where your approximation comes. Okay, magnitude of this is 10 to the power of 6 times 9. Why? So magnitude of A I cap plus B j cap plus C k cap is given by, magnitude of this is given by square root of A square plus B square plus C square, right? Now if you see, this is very small number, less than 1, this is also very small number, less than 1, so we can basically ignore B square plus C square. Only thing that will remain is A square, so that is equals to A. So we have written it, approximated value of this value. Now what was the magnetic force? What is the Lorentz force? Lorentz force was given by Q times this value, that is 10 to the power of 6 times 9, and that is the proton. Proton was given. Okay, so what is the charge of a proton? charge of a proton is 1.6 times 10 to the power of minus 19 times 10 to the power of 6 times 9. So it will be 9 plus 5.4. So it will be 14.4 times 10 to the power of minus 13 Newton. Okay, 14.4 times 10 to the power of 13 Newton. So approximated answer will be this. Okay, this is the closest answer. So 15 times 10 to the power of minus 13 Newton, right? This is very close to our actual answer. Now, a solenoid of length 50 centimeter having 100 turns carries a current 2.5 ampere. The magnetic field at one end of the solenoid. So what is the thing? It is given as the solenoid. Now I told you, when you are calculating the at one end, whatever is in the middle, it should be half of that. Okay, so what is the magnetic field at the middle? At the middle, the magnetic field is given by mu naught Ni. Here N is the number of turns per unit length, right? And at here magnetic field will be mu naught Ni by 2. I have discussed this in the lecture. If you missed it, please go back and check. I have solved the same problem there as well. Now a magnetic field is given by, now what is the length? Length is 50 centimeter and turns is 100. Okay, so for 50 centimeter length, number of turns was 100. Okay, for 100 centimeter length, number of turns should be 200. Now what is 100 centimeter? 100 centimeter means 1 meter, right? So the number density small n is 200 per meter, right? So this is the number density. So we calculated number density, and we also know that mu naught is equals to 4 pi times 10 to the power of minus 7. So let's put these values here. 4 pi times 10 to the power of minus 7 times n is 200 times I is given 2.5 divided by 2, right? Four fives are 10, 1000, 3.14 times 10 to the power of minus 7. Pi is 3.14, right? This times this is 10. 10 times 100 is 1000. Okay, if you are still wondering how I have calculated, 10 to the power of minus 4. Okay, Tesla. 3.14 times 10 to the power of minus 4 Tesla. You have to solve these problems very quickly. A strong magnetic field is applied on a stationary electron, then the electron will remain stationary. Force, magnetic force is QVB. V is 0, so the force will remain 0. If there is no force, it will not move, right? First law of motion. Two parallel wires in free space are 10 centimeter apart and each carries a current of 10 ampere. Now, while doing the regular classes, I have done a mistake. I said if the current is going in the same direction, they are repelling each other, but actually when the currents are going in the same direction, they are attracting. If the currents are going in the opposite direction, they are repelling each other. Okay, that was a mistake I have done while taking the regular class. So don't, I am correcting that mistakes here. So two parallel wires in free space are 10 centimeter apart. So distance is 10 centimeter. Okay, 10 centimeter means 10 times 10 to the power of minus 2 meter, right? Now what else? Carries a current 10 ampere in the same direction. Both of them are carrying 10 ampere current. Okay, the force exerted by one wire on the other. So force exerted is mu naught by 2 pi, or what I have done, mu naught by 4 pi 2 Ia Ib by d. Okay, force exerted per unit length. For that formula I have used small f. This is the formula for that, right? So mu naught by 4 pi is 10 to the power of minus 7 times 2 into 10 times 10, both are 10 amperes. Distance is given by 10 times 10 to the power of minus 2. Okay. So what you can do, you can cancel 110 here and make this minus 5. Okay, minus 2 was here, so it will be reducing this minus 7 by 2, right? So we can write this as 20 times 10 to the power of minus 5 or 2 times 10 to the power of minus 4. Okay, you have to be very fluent with 10 to the powers. You have to be very fluent with 10 to the powers to be able to successful in physics. Next problem. A toroid, even though it is deleted, I am just giving you the hint. A toroid, inside a toroid, the formula of magnetic field is same as that of the solenoid, mu naught Ni. Okay, and as you can see, this is a constant. It does not depend on the inner or outer radius of the toroid. Only thing, it exists only inside the toroid, and outside the toroid it remains 0. Okay, that is one of the thing in the toroid. Okay, so the correct answer is option D. A tightly wound long solenoid has n turns per unit length. A radius r carries a current I. A particle having charge q and mass m is projected from a point on the axis in the direction of perpendicular to the axis. The maximum speed of the particle for which the particle does not strike the solenoid. So what is the magnetic field inside the solenoid? I just said in my previous problem, mu naught Ni, right? Now this problem is particularly interesting, otherwise very boring problem. Only thing is you have to read this question very carefully. Particle is thrown along the axis. Okay, if it is thrown along the axis, we know that inside a magnetic field a moving particle rotates in a helical motion. Okay, or at least a circular motion. If there are no other component, parallel component is present, it will move in a circular motion. Now let's assume it is moving in a circular motion. So how much maximum it can move so that it does not touch the outside, because it is being projected from here. So maximum it can rotate like this, right? So the maximum, this is the diameter. This is the diameter, means what is the radius? Radius should be r by 2. So r by 2 is the radius. Now we know that the force acting on that charge is given by QVB, that should be equals to, sorry, not QVB, QVB equals to mv square by r, right? Here r by 2. Okay, that is the basic formula that you have to remember every time you are solving magnetic field. Okay, this is very important formula. So v is cancels. Okay, they have asked you to find the maximum velocity, so you are calculating v. So v equals to qb times r by 2, qb times r by 2 divided by m, right? Now what is b? b is mu naught Ni. Okay, so let's put these values one by one. Q times mu naught Ni r divided by this 2 will come down and it will become 2m. So you can write this as mu naught Ni qr by 2m. Okay, so mu naught Ni qr by 2m. So this is the only catch. Okay, if it is if they have not mentioned anything, if they mention that one charge particle is thrown from a single side, one side of the solenoid, then you have to take in the radius completely, that is radius r. Okay, but they have said it is thrown along the axis. Along the axis means maximum radius of the circle should be r by 2. That is the only catch of this problem. Now This is a somewhat between this chapter and the next chapter. Now magnetic field lines for any magnetic field is always closed. So, and we know that equipotential lines can be of the circular way. So this is the only correct answer. Okay, this is possible for both electric field and magnetic field. Sorry, not this one, but this one is possible for both electric and magnetic field, because if there is a positive charge, there is a negative charge. Okay, this kind of magnetic field lines you have seen for north pole and south pole. Only thing is, for magnetic field lines can exist inside, but for electric field lines cannot exist inside. Okay, that is the only difference between these two fields. We are going to discuss that in our next chapter. The magnetic field at the origin due to a current element dl placed at a point with a vector position r is. Now I told you this is the correct answer. When you are using a vector sign at the numerator, then there should be r cube in the denominator, right? You cannot use that. This, if you are using r square, then it has to be r cap. Okay, that is the only catch. Very simple question. Now I remember I have solved this question during one of my regular classes. The first thing that you have to do is, the given figure magnetic field at O. So they have asked you to find the magnetic field at O. So what you have to do, you have to first you have to complete this line. Okay, you have to complete this line so that it becomes an infinitely conducting wire. Okay, now then we know that if the thing is completed, what is the magnetic field at the center? Okay, only due to the circle. Okay, due to the full circle. We know that it is mu naught I r square divided by 2x square plus r square, right? I have just used that formula. Now here x is 0. Okay, x is 0 means it will be r cube. In case you remember the formula, you can use the formula directly. Now so r square and r will cancel, so only mu naught I by 2r. So this is the formula for full circle. Now full circle means how much part are there. So if you see, there are one part, two part, three part, but the fourth part is missing. If fourth part is there, then this would have been the magnetic field, but fourth part is missing, so the actual magnetic field will be 3 by 4. This is for the 4 parts, but this is for 3 parts. Okay, this is the magnetic field due to the circle. Okay, now you have to calculate the magnetic field due to this wire. Now to find the magnetic field due to this wire, I have doubled this wire. Okay, so actual magnetic field will be half of that. Okay, so for a single straight current carrying conductor, what was the magnetic field? If you forget, I am giving you a way to remember that. This is a wire. Okay, this is the circle that we have constructed, and we said B times 2 pi r is equal to mu naught I. Remember that? So B due to the wire, okay, current carrying wire, say Bi is equal to mu naught I by 2 pi r. You have to remember these formulas by heart. Okay, but in case you forget, you can remember it like this, and this is going to be added because this is in this direction, this is also in this direction, so both will be added, right? So magnetic field due to this straight wire is, magnetic field due to straight wire is into the paper, and magnetic field due to this wire is also into the paper. Yes, so they will be added. Okay, I told you how to remember the direction for any current carrying wire. You have to arrange your fingers like this for a loop. Okay, and the thumb points the direction of magnetic field. For a straight wire, you have to arrange your thumb in the direction of current, and you have your fingers points towards the magnetic field. Remember that, right? Now let's start. So but it is due to the entire length of the wire. We have only half of that. So actually here it will be half times mu naught I by 2 pi r, right? Because that is only half of the wire is present. This is not present. This is only we have drawn to calculate the magnetic field. So the correct answer is 3 mu naught I by 8 r plus mu naught I by 4 pi r. Okay. So 3 by 8 mu naught I by r plus mu naught I by 4 pi r. So correct option is option number A. Okay. One interesting pattern I have observed, though it is not valid for all the questions, all the papers, but most of the cases if the question is complicated, the correct option was turning out to be option A. Okay, but it may vary from paper to paper, option to option, because they change the options and questions, so maybe not. But from my experience, I am seeing if the question is little complicated, correct option turns out to be option A. A long cylindrical wire of radius r carries a uniform current I flowing through it. The variation of magnetic field with the distance r from the axis of the wire shown. So I have solved this problem as well. Okay, so this is the current flowing in the circuit. Okay, and if this is the part, suppose this area is A dash. Now we have calculated the current density in the circuit, total current I divided by pi r square. Suppose this distance is r. Now if this distance is smaller, then the current enclosed is given by J times pi small r square, right, or I small r square divided by r square. Now from Ampere circuital law, we know that B times 2 pi r equals to B times 2 pi r equals to mu naught I enclosed. I enclosed is pi r square by r square. So B equals to 1 of the r will cancel, mu naught I r divided by 2 pi r square. Now remember, this r square is constant, right? So inside the wire magnetic field is varying as r. Okay, outside the wire magnetic field is varying as 1 by r. Okay, so inside the wire the magnetic field will slowly increase in a straight line. Okay, proportional means straight line, and as it is decreasing, 1 by r means it is decreasing, right? So proportional to r means it is increasing with distance, proportional to 1 by r means it is decreasing with distance. So correct answer is option A. Now cyclotron is out of syllabus, but I will just briefly touch this, that kinetic energy is proportional to q square by m. Okay, so alpha particle has q is equal to plus 2, whereas hydrogen and deuteron has q is equal to plus 1. So for for helium, the kinetic energy will be higher because it is 2 charges, so it will be 2e, so it will be 4e square, even though the mass is 4 times. Okay, so it will be equal to that of the protons. But for deuterons, mass is 2m, but charge is same, so it will be less, minimum for deuteron, not for helium as you might think because of the mass. Okay, or maybe you are thinking that okay, mass is more for helium, so kinetic energy should be more for helium and less for hydrogen. So this is a very confusing and good question if cyclotron was included in your syllabus, but it is no longer there, so no need to worry about it. Two long straight parallel wires are at a distance 2d apart. They carry steady current equal currents flowing out of the plane of the paper. The variation of magnetic field B along the line xx dash is given by. So what is the thing? So we have 2 wires, okay, and 1 plane. I am drawing it in a different way. Okay, 2 long straight wires are at a distance 2d apart. They carry steady current equal flowing out of the plane. So both are carrying steady current I. Okay, their distance is 2d apart. Okay, now they have asked you find the magnetic field B along the line XX given in that plane. To solve this problem, let us draw the magnetic field lines. Okay. Magnetic field lines will be like this. For this also it will be like this, and here it will be like this, right? So it will be concentric circles. Okay, here, here, same here, here, here. Okay, now let us assume that this direction of magnetic field along the plane, sorry, maybe you are thinking upside, not upside. Along the plane, the magnetic field is positive in this direction and it is negative in this direction. Okay. Now, if the magnetic field is positive in this direction, okay, because it is moving in this direction, now what is happening at the center? At the center, if you see, the magnetic field due to this and magnetic field to this wire, they are cancelling each other, right? So, the magnetic field here is 0. Magnetic field at the center must be 0. Now, if this side magnetic field is positive, then this side the magnetic field is negative. Similarly, if the magnetic field is positive in this side, this way, that is when they are moving in the this side direction, then magnetic field will be positive here also, and here it will be negative, right? So, what we can see that magnetic field is changing like this. So, on left hand side, because this is given like this, I am drawing it like this. If they have given a graph like that, then I would have taken this side as positive. So, you can understand. So, we know that. So, this half. So, let us divide this into different halves. Okay. So, this is the half d by 2. So, that is d. This is also d. Okay. From this half, okay, the magnetic field is 0 at the center. Okay. Up to this wire, this is positive. So, magnetic field is increasing. Then it becomes 0. Then on the other side of the wire, magnetic field is negative. Okay. So, magnetic field is negative. So, it is increasing like this. It is coming like this. And this side magnetic field is positive. Positive means in the positive axis. And this side the magnetic field is negative. So, negative means this is the negative sign. Right. Below means negative. Up means positive. So, the correct answer is option D. Okay. Now, let us move on. A toroid has 500 turns per meter of the length. If it carries a current 2 ampere, the magnetic energy density inside the toroid is, this is no longer part of your syllabus, but magnetic field density of a toroid is given by U equals to half B square by mu naught. Okay. B is equal to mu naught Ni. Okay. So, you can use this formula and calculate this value and tell me the answer. I am not going to solve because this is no longer part of the syllabus. In a cyclotron, the charged particle speeds up in d, undergoes acceleration all the time. It undergoes acceleration all the time. I am not going to explain. Okay, it is deleted. The number of turns in a coil of a galvanometer is tripled. Then both voltage and current resist sensitivity remains constant. Voltage sensitivity increases 3 times and current sensitivity remains constant. Voltage and current sensitivity decreases by 33%. Voltage sensitivity remains constant and current sensitivity increases by 3 times. So, we know that current sensitivity is given by, current sensitivity is NBA by K, right? So, NBA by K, so that is the current sensitivity. Now, if we increase this number of turns to 3 times, then it will become 3N BA by K. So, we can see that current sensitivity becomes 3 times, right? So, now voltage sensitivity is NBA by RK. Now, if you increase the length, basically increasing the number of turns 3 times means not only the number of turn is increasing, you are increasing the length of the wire also. If you increase the length of the wire, your resistance will also increase, right? So, resistance will also becomes 3 times. So for 1 turn the resistance is R, for 2 turns resistance will be 2R, for 3 turns resistance will be 3R, right? So basically what is happening, voltage sensitivity if you see remains same. Voltage sensitivity remains same when you are tripling the number of turns, but current sensitivity becomes 3 times. So current sensitivity increases, voltage sensitivity remains constant, and current sensitivity increases by 3 times. So correct option is option D. This is a very interesting question. Now next question, a circular current loop of magnetic moment M in an arbitrary orientation of external uniform magnetic field, the work done to rotate the loop by 30 degrees. So now any arbitrary magnetic field is there and there is a loop. Okay, now if you rotate the loop, the magnetic field, relative magnetic field does not change, okay, because you are rotating the loop like this. Unless or until you are rotating the loop like this will not change anything associated with the loop, so the work done will be 0. Question number 25, another interesting question. The magnetic field at the center O of the given figure is, okay, we have already solved a similar problem. Okay, that case it was given like this. If you remember, that problem was like this, but here they have given in angles. Okay, so what was the magnetic field due to the entire circle? If you remember, the magnetic field due to the entire circle was given by mu naught I, okay, divided by 2R, okay, 2 capital R, right? So if you can simplify that formula that I gave you, mu naught I R square divided by 2 R square, x square plus R square to the power 3 by 2, if you simplify, you would have gone this formula. Now this is for how much? This is for angle 360 degree, right? This is the meaning of unitary method. When you are using unitary method, first of all you have to divide for whatever value is given, and whatever value you want to calculate, that should be in the up, right? Why 300 degree? Because this gap is 60 degree. So how much is this? This gap is 60 degree, means this should be 300 degree. Simple. 360 minus 60. So now simplify this. 5, 6. So 5 mu naught I divided by 12 R. So 5, where is 5? Yes, 5 mu naught I by 12 R. Okay. The correct Biot-Savart law. Again, this question comes again. Okay, correct Biot-Savart law is this. This is a very, very, very important question. Comes twice in the previous year question. Now, an electron is moving in a circle of radius R in an uniform magnetic field B. Suddenly, the magnetic field is reduced to B by 2, the radius of the circular path. Again, same formula, mv square by R is equal to QVB. Okay, so R is equal to mv, 1v cancels, mv by QB. Now what they have done, they have reduced the magnetic field to half. So R dash is equal to mv divided by QB by 2. So it will be 2 mv by QB. Okay, so R dash is twice of R. So it will be 2R. Next question. A charge Q accelerated through a potential difference V. It is then passed normally through a uniform magnetic field where it moves in a circle of radius R. The potential difference required to move it in a circle of radius 2R is. So a charge Q accelerated through a potential difference V. The potential difference itself is given. Okay, potential difference itself is given, and we know that the kinetic energy or the energy stored in that process is given by half mv square. That should be equals to Q delta V, that is QV in this case, right? So what we can do is V equals to QV by 2QV by m, right? This is the velocity. Now what they have said, that if you want to increase the radius of the circle by 2R. Now what we have calculated in the previous problem, R equals to mv by QB, right? In our previous so many problems we have used this formula. So R is equal to mv by qb. So we can see that R is basically proportional to the velocity. If m and qb are constant, obviously m is constant, qb is constant, right? So only way we can increase the R to 2R if we increase the velocity to 2v, right? If we increase the velocity to 2v, okay, then the radius will also become 2R, right? Simple, straightforward proportionality. Now how we can increase the velocity to 2v? If we increase the potential difference to 2v, then velocity will become 2v. Okay, so in that case what we have to do, we have to increase the potential by twice. Simple problem. Sorry, my mistake. It is to be square root. I made a mistake. So it will be square root of v. Okay, so if we want to increase v to 2v, what we have to do? We have to use this. Okay, v to 4v. If we increase v to 4v, okay, then only v will become 2v, right? There is a square root relationship. So v basically proportional to square of potential difference. So if we increase it by 4 times, then only velocity will become twice, right? A straight wire of length 50 centimeter carrying a current 2.5 ampere is suspended in mid-air by uniform magnetic field 0.5 Tesla. The mass of the wire is. So there is a wire, it is being suspended, magnetic force is acting upward and weight is acting downward. Weight is the mg and magnetic force is Bill Clinton, I told you. Okay, now since they are perpendicular, we are not using Bill sin theta. So magnetic force is B is given by 0.5 Tesla. Okay, current is given 2.5. Length is given 50 centimeter. 50 centimeter means 10 to the power of minus 2. Okay, this is the magnetic force. What is gravitational force? Gravitational force. Okay, m times g. This is the gravitational force. Now we know that this force should be equals to the gravitational force. So 0.5 times 2.5 times 50 times 10 to the power of minus 2 should be equals to m times 10. See, on our left hand side we have written so many things, on our right hand side we have only written so little things, right? So m should be equals to, if you see 5.5 is 5 5s are 25, so again 2.5 times 2.5 times 10 to the power of minus 2. So if you multiply them, it will be 6.25 times 10 to the power of minus 2. This is kilograms. Okay, everything is in SI unit, so answer will be in kilograms. Now answer options are given in grams. To convert kilogram to grams, what we have to do? We have to multiply it to 10 to the power of 3, right? So answer will be 62.5 grams. 62.5 grams. Okay, if I was forming this question, instead of giving 62.5 grams, I would have given 6.25 kilograms. Most of the people after solving up to this much, most of the people will ignore this 10 to the power of 2 and they will answer 6.25 kilograms. Okay, so don't get confused. You have to convert the unit properly, then only you will be able to solve this question. Last question of today. The magnetic field at the center of a current carrying loop of radius 0.1 meter is 5 root 5 times that of point along its axis. The distance of the point from the center of the loop is. So very interesting question. So we know that magnetic field at the center of the coil is given by, I have used this formula many times today. So this formula is very important. Okay, 2R. Right, this is the magnetic field at the center. I have used capital R, sometimes small r, sometimes capital R, but let me use capital R for this problem. And it says that it is 5.5 root 5 stronger than that of at some point, okay, at some point, say at a distance x. So for that point we can write this as 2x square plus r square to the power 3 by 2, right? We know this formula. Now if we compare, we can cancel mu naught I, okay, and then bring it on to this side. 2 also cancels. So x square plus r square to the power 3 by 2 equals to 5 root 5 r cube. Okay. Now what we have to do first? We have to take care of this by 2. I told you previous time also. So we have to take care of this by 2. So what we have to do to take care of this by 2? In this case, what we will do? We will square of both side. We will square both side. Square both side means this will cancel, right? Here I will get 5 root of 5 r cube whole square. So that means 25 times 5 times 10 to the power r to the power of 6, right? Now we have to do cube root on both sides, right? Now we got x square plus r square whole cube, right? Whole cube, right? So to remove this cube we have to use cube root on both sides. So if I do cube root on both sides, then we will get on this side 25 into 5 cube root. 25 into 5 cube root means what? 5. Yes, 5 5 5. 25 means 5 times 5, another 5 is there, cube root means 5. Now r to the power 6 cube root, r square. Yes, so we can say x square equals to 5 r square minus r square, that is 4r square, or x equals to 2r, right? X equals to 2r, plus minus 2r, but that is for mathematics. For in physics we always take positive values. So correct answer is given the radius was 2 meter, so radius was 0.1 meter, and our answer is x equals to 2r, that is 0.2 meters, right? So 0.2 meters is the answer. So we have reached at the end of today's lecture, and if you are not yet subscribed to our channel, don't forget to subscribe to our channel. Also we are arranging weekend KPL exam every week, so don't forget to join our WhatsApp channel so that you get that question paper on your mobile, on your laptop, and you can solve it. Okay, thank you. I will see you tomorrow.